Now for the seventh question of this paper, we are given this circle with center O and radius R. Now there are two sectors which can form inside a circle when we are trying to divide it into sectors. So one is the minor sector and other one is the major sector, the one that is right opposite to it. So if this is x radians, this becomes from whole to pi. If you take away x, you will be getting this angle, and that will be 2 pi minus x. And now it's also given that the area of this major sector is 3 times area of the shaded region. So the thing that is given to us is major sector area is equals to 3 times shaded area. So if you know how to find the area of the major sector, if you know how you can find out the area of the shaded region, you just need to equate them and try to get this equation, because that's something that we have to prove in the first part. So now area of the major sector, how do you get area of sector in the first place? If this is the kind of a sector, if this is r and if this is theta, the area of the sector becomes half r square of that angle of that sector. So over here, this will be same as writing half. The radius is r, so it becomes r square. And for the angle, it's not theta, it's 2 pi minus x. So this is 2 pi minus x. It's equal to 3 times the area of the shaded region. Now for this shaded region, what we can do is, from this area of whole sector, if we take away the area of the triangle, this triangle, we'll be left with the area of the shaded region. So what's the area of the minor sector? It's half same radius, so r square, and angle this time is x, so it's x, minus, how do you find out the area of a triangle which is having theta like this, and if this is r, if this is r, that's the kind of stuff, right? This is r, and this is some angle that is known to us. So always this kind of area, always this kind of triangle has an area of half the product of the adjacent side times sine of the angle that's shared by the adjacent sides, and that's area of triangle. So if you use this over here, it becomes half r square sine x. So now we are just trying to get this form into this form, and that's it. We'll be done with the first part of this question. So first of all, we can say that r square is common in all the terms, so I'm getting rid of this. And if I open the brackets, I'll be getting pi minus x by 2 is equals to 3 by 2x minus 3 by 2 sine x. Now, if I try to take x on the same side, so this will become pi plus 3 by 2 sine x is equals to 3 by 2x plus x by 2. So 3 by 2 plus 1 by 2 becomes 1. I mean 4 by 2. So that becomes 2. So 2x. Now, if I make x the subject, therefore I'll be getting x is equals to divide both sides by 2. So pi by 2 plus 3 by 4 sine x. So 3 by 2 divided by 2 is 3 by 4. And then plus pi by 2. And that's something that we wanted as the answer. So yeah, that's it. The common practice for this kind of question is to always read out this kind of hints. This kind of hints will lead us to that kind of solution. Okay. So the major sector, we found out what's the area. The shaded region, we found out what's that area. We multiplied it that by 3. And then after that, it's just a normal algebra. If you are good with that, we just need to make sure that x becomes the subject. And yeah, we are just following the steps and finally proving that this is our answer of the first part. So yeah, that's it for the first part of this question. Let's move on to the second part. And if I scroll down, we are asked to show by calculation that the root of this equation that we got in part A, which is nothing but x is equals to 3 by 4 sine x plus pi by 2. We have to prove that the root lies between 2 and 2.5. So what happens over here is we try to convert everything onto one side and say that this is nothing but your f of x. So this thing can be written as x minus, or maybe like 3 by 4 sine x plus pi by 2 minus x is equal to 0. Now you consider this whole thing as a function of f of x. So let f of x be equal to 3 by 4 sine x plus pi by 2 minus x. Now this implies that f of x is equal to 0. Okay, now if we are saying that f of x equal to 0, and if we are plotting, like if we are substituting the value of x as 2 and 2.5, if the value of 2 gives, let's say, a positive value, and if the value of x over here, if we substitute and it gives a negative value, it automatically means that in between them, there must be some zero value, right? That's the reason why it's changing the sign. So if I have to draw an example over here, let's say this is the curve, some kind of a curve like this. And let's say that 2 is over here, 2.5 is over here, and this is nothing but the equation of f of x. So when you put x is equal to 2, let's say you get some positive value. When you're putting x is equals to 2.5, let's say you're getting a negative value. It confirms that at least once, right? At least once in between, we are having a root. Only then we are having this kind of relation, right? Or else this kind of relations cannot be formed. Let's say 2.5 was over here, you would have got a positive value. We would not be able to say that, there is a root in between 2 and 2.5. But now, because this kind of condition will form, we can say that yes, root is lying in between 2 and 2.5. Now, these are the kind of classic questions. So if you are someone who is new to this, you always try to make this equation into one side, convert that into f of x equal to 0 format, then put 2 and 2.5, one will come out to be positive, other will definitely come out to be negative. And therefore, because there is a change in sign, we confirm that the root lies in between them. So therefore, f of 2, if you find it in your calci, make sure that the values of your sign and everything is in radians, because we are dealing with radians. So 3 by 4 times sine of 2 plus pi by 2 minus 2. Now this gives a positive value, 0.25 to 0.253, for example. Let's this is correct to 3SF. Now f of 2.5, I just need to replace all these 2's to 2.5. So let's see, what do I get now? I get a negative value, negative 0.480, correct to 3SF. And because there is a change in sign, I can conclude that as f of 2 and f of 2.5 as change of sign, this proves that root must lie between 2 and 2.5. Just write between in a proper way, but yeah, that's the way that you write your conclusion. So now this is the answer of part B of this particular question. Let's move ahead. Let's see if there is part C. Yes, there is part C. We have to use an iterative formula based on the equation that we got in part A. So what is the equation that we had got? It was x is equals to 3 by 4 sine x plus pi by 2. Now we have to use the iterative kind of process to calculate that value of x correct to 2 decimal place. And we have to give each iteration's result correct to 4 decimal place. So now we know that root lies in between 2 to 2.5. We can start our initial value. Because the initial value is not given over here, we can say that our x1 is the value that starts in between 2 and 2.5. So what's the value that is in between 2 and 2.5? That's 2.25. So 2.2500 is the first value that we are going to take. That's what we are going to put over here to get the value of x2. So x2 is 3 by 4 sine of x1 plus pi by 2. And if you take this and put this into your calci, so 3 by 4, what I am doing is I'm first of all in my calci writing 2.25, pressing equal to, so that my answer variable is having this value. Now I'll be writing 3 by 4 sine of answer plus pi by 2. 3 by 4 sine of answer plus pi by 2. So every time I just have to now press equal to sign, so that I don't have to keep on fixing the values of x1, x2, x3 in to get the upcoming values of x2, x3, x4, whatever it is, right? So that is a very good trick if you want to use that. So now the next value that we're getting is 2.1544, correct to 4 decimal place. Then x3 is coming out to be, if I just press equal to sign, this is nothing but 3 by 4 sine of x2 plus pi by 2. And see, instead of x2, I am just having the answer variable which stores the value of this. And then now the next value is coming out to be 2.1967. And x4 comes out to be, this is 3 by 4 sine of x3 plus pi by 2. This value is 2.1763, correct to 4 decimal place. And the last iteration. Uh, no, it's not last because we are not converging. I thought there are only the first 4 values. We are already done with that, but no, we have to get to an answer where the values are converging. The values are not converging, so we can keep on going ahead. 3 by 4 sine of x4 plus pi by 2. This is coming out to be 2.1786. We can see that the values are converging now, right? Let's try 2 more. So 3 by 4 sine of x5 plus pi by 2. This gives out the value of 2.1865 for VP. And x7 comes out to be 3 by 4 sine of x6 plus pi by 2. And it's coming out to be 2.1831. Again, we are still not able to see that if 2.18 is the answer. I guess one more iteration would help us confirm our answer. 3 by 4 sine of x7 plus pi by 2. And this value comes out to be 2.1845. 2.1845. I guess one last would be much more better to identify that that's our solution. And this value is 2.1832. Now this confirms that correct to 2 decimal place, as we can see. Here is 2.18, 2.18, 2.19, 2.18, 2.18, 2.18. Now we are having enough evidence to say that the root of this equation, which is x, comes out to be 2.18, correct to 2 decimal place. So now that will be the answer of part C of question 7.